So today I thought we'd spend a little bit of time talking about tuples. Tuples are an important basic data type available in Elixir, and they get used in a lot of places, so I thought we should spend some time talking about them because they're also pretty interesting. So we're going to fire up the interactive Elixir prompt, and a tuple is defined simply by putting things inside curly braces. So in this case, let's make a tuple about our friend Fred. And we will say that Fred, his name is Fred, he's 43, and he's male. And you can see simply returns the tuple. We can set that entire tuple equal to a variable. If we print out x, you can see that we get the entire tuple. There's also a function called elem, which will tell you the value of a particular element within a tuple. And you can see, like any good programming language, Elixir counts from 0. You can also do pattern matching against tuples. So we could say, for instance, that we want to find the name, we don't care about the age, of anyone who is male. And we can set that equal to x, and we didn't get an error, the pattern matches, and if we show the value of name, we'll see the name now holds Fred. So this is a way you can sort of unpack a tuple, if you will. And if we went back and looked for a female, we will get an error telling us that there's no match between the patterns on the left and the value on the right, which is exactly what we want. So tuples get used a lot in responses from standard library functions. You'll notice them in a lot of the file I/O returns, say a status, potentially OK or error. Let's see if we can do. Oh, I think it's this. Okay, so that didn't work. So some of the file methods, specifically open, I know will either return OK and a handle to the file or potentially return error. And the OK and the file handle are returned as a tuple. You can also use tuple as we were as a data structure, and you can actually iterate over them. So you can also make a list. So a list is another fundamental data type in Elixir. And a list is simply, you can think of it as an array, but that starts you down a dangerous path. So let's see. So now X is a list, and we can also pattern match against a list. Say we want the first value to be 1, we don't care about the second value, and the last one we want to catch as the name equals X, and now if we print name, it's still Fred. Okay, so you can make a list, and in fact we could make, let's go back and make X equal to our friend the tuple up here, and we will make Y and now we can say oh, better not. My list equals X comma Y. And now we can see that the list has both the tuples in it, and the tuples are fully constructed. So I said lists weren't arrays, and it's important to realize that lists are really in Elixir implemented as linked lists. There's not a way to specifically represent or to identify element number 1 or element number 2. There is a way to traverse the list, though, using a particular kind of pattern matching operator where we match the head to one element and the rest of the list to another. So actually what I'm going to do here real quickly is like Barney, we're going to go back here just not to confuse things. We're going to redefine my list, and I see my list has all 3 variables. So the particular kind of pattern matching that is available against the list is this little operator here with the pipe operator in the midst of the square braces. And what that's going to do is it will take the first element of the list and assign it to the value head, and it will take the rest of the list and assign it to the variable tail. So in this case, we could do this again, and now head will be Wilma and the tail will be Barney. We can do it one more time. The head is Barney, the tail is the empty list, and if we try this one more time, we'll get an error. So you can match a head and a tail when there's no tail, but you can't match a head and tail against the list when there's no head. So this is a edge case that is where creating looping structures will need to account for. So if you know, tuples are stored next to each other in memory. They're all allocated at the same time. So when we said Wilma 40 and female, they were all allocated memory right next to each other. The list isn't. So that means that when you're traversing a tuple, it's really fast to traverse a tuple, which is why they were nice enough to give us the element or the elem function. It's not so fast to traverse an array. And you'll also find that it's very easy to add things to a list, but you will find it very difficult to add things to a tuple. At least difficult from a copying perspective, where you'd add something to a tuple. Frankly, I'm not even sure how to do that, but if you were, it would end up copying all of it in memory and then adding the new element right behind it. So the other thing we can do, if we want to add, let's make a tuple for Betty, and let's say Betty's 39 and she's female. We could add this to my list with actually the same pipe operator. So we could add it to the head by saying my list equals, and now if we print the value of my list, we'll see that Betty's been added to the front. So that's a little bit about tuples, a little bit about lists, and a little bit about how to the pattern that we'll use for traversing a list. So let's hop over here and let's make another example program. And we'll print all the members of a list. And obviously, I shouldn't say obviously, Elixir has functions to do this already, but I wanted to make a point about how we traverse a list, and so we'll do it this way. So we'll need to define our method print, and it will need to take a list. We will say, and the variables don't have to be head and tail, they could be really anything as long as they're in the square braces. And they have the pipe between them. Actually, let's do this. Make this more clear. So here we go again with the tail recursion. So you can see we pass in a list of anything really. We pop the first thing off using this pattern matching operator. We print it, and then we call ourselves with the rest of the list. So let's. All right, and now, so we ran the program. We'll see that we got an error because we did not handle the terminal case of an empty list. So there's a couple things that we'll do while we're improving this. So the first thing we can do is actually, rather than catching a list, we can go ahead and have the pattern matching happen in the definition of the function. Let's just make sure it still works. Yep, same issue. Okay, good. So that's a little faster, and you can use this pattern matching to actually help us with the terminal case. So in this case, let's see how we did. Unexpected token end. Oh, right, of course. I like to do that. Same issue. So now the question is, why did that happen? Oh, hold on. There we go. So I think it's this. There we go. All right, so I warned you before about guards sometimes failing quietly. That was a case where the guard was failing quietly. So here what we did is we said, let's keep calling with the list until the special case when the rest of the list is 0. In that case, we'll just print this word, and then we'll be done. We also could have, so when you're doing when you have the parameter separate the head from the tail, this is the way to do it. Were we passing in the list and then separating the head and tail ourselves, we could do it when the list is equal to 1, or even when the list is equal to 0 and not do anything. So here's an example. We just wrote a little program to iterate over a list, and again, use function, pattern matching, and guards to help us do the right thing. And hopefully this was another helpful episode.